There is the sample.
That's it.
I don't think.
So it's just my greens.
No, it smells nice.
So it was found in a monastery, you said, right?
Yes. Do you see just a few drops? And this is perfect sample because you see it's very easy to add. It's
Yeah.
not water, so
Yeah.
it's with alcohol around
Right.
40%. It's
Right. So it's
It's
really
not
perfect.
that strong though. It's
So now you're gonna get electrical signals.
hopefully. Fingers crossed. We are getting there. Okay.
It's the first
Okay.
archaeological
It's the
sample.
lounge.
Okay, so we
Yeah,
have
but-
potential
So
plotted
that's
against
like a
the current,
Yeah.
voltage against microamperes.
This is sample number 4.
Uh-huh.
So it would be as simple as this, you know, you take this drop and we're already running the measurement. And after we need to, wow, this sample is fancy, I'm telling you already.
Yeah.
You see some oxidation process happening. It will take some time to think for me what is exactly is oxidizing there, what material is present there. But I could definitely say.
I was making a drawing like of some foxes.
Yes.
Bottle, you know, it's like.
The way it would work, we could make different concentrations.
I think the two axis is going to be.
Have you seen such a curve before?
Yeah.
So this is basically a time plot, right?
Galima padaryti.
So meter. Okay.
So what is the scan 2? The red
Ne,
one?
antras ciklas čia matuoja dar.
Ah.
So there's two types of scans. Is it green? The red
So
is
there are like 3 scans.
yeah.
One first scan, second scan, we see how stable is the process. And also we can analyze how fast is the process as well regarding the oxidation and reduction.
Okay.
And I'm so surprised. We might run later some controls, but we definitely have something. And I think next step would be to compare analyze different samples from different species or
Oh, you mean like repeat it on the
not
same?
repeated, but
Yeah.
maybe it could be another electrode. I know them well.
Oh, I
It's
see.
made of
Oh,
carbon.
different electrodes.
Different
Oh.
alcohols or drinks. Whatever
Oh,
we have
that's what you
here.
mean. Like put a different
Yeah.
because each electrode measures
Yes,
different
each and
properties.
It should be similar response.
Right. Oh, I see.
So you would need to like set up a reference library of possibilities.
Yeah, but I did
now
set-
you have the sample, and then you would test like various types of whiskey and vermouth and
Yeah.
different types of liquors, and then see which one is the closest match.
Perfect. Yeah, it's a very analytical idea, and I did measure blank already before, so I will add the blank on this system, and we can have it.
I mean, I have methanol, but
But since I already have experience, I know that there's something happening already, and it can turn later to
because I
technology.
have ethanol and I have methanol in my lab. Maybe it tells you something because if it's alcohol, it should have ethanol.
It could be a control, so we can think of controls like having ethanol and some other. We have to make a list of compounds could be present there.
Do you want to smell?
It's so sweet. It reminds me of syrup, maybe honey or something like that.
That's maybe. Then I opened it. The whole lab smelled like whole corridor smelled like exotic passion fruits and it's from Lithuania. Back,
You see?
it's like from in the middle of nowhere. And here we have all this liquid in a wall.
But you said it was found inside a vat, right? A vase in
Bottles,
buried
just
bottle.
glass
Just bo-
bottles,
yeah,
yeah.
but
Glass
buried
bottle,
underneath in the
Deep
monastery.
underground, somebody was hiding this precious thing.
Some naughty Lithuanian monk from 1700s. Cool.
So I guess the bottles, it would have been airtight, right? So once the bottles now were opened and you took the samples to the lab, the oxidation would have started as soon as the original bottle was opened,
As soon
right?
as we took them out of the sediment, out of the ground, the cork started to shrink and air started. But of course now my bottle, they all were kept in the refrigerator with a very airtight bottles, airtight corks. So yeah, so I hope not much oxidation.
Very, very good data.
No.
So these are
Very
time
interesting.
lapses, right? As the curve
Yeah,
moves,
so I just repeat to see how stable is the reaction.
Yeah.
And the top one is oxidation. It's like
Right.
chemical present there is oxidized, and later it's reduced right here.
Okay.
We have even electrode charge transfer here. Yeah, I think definitely we might do a couple of controls to see and understand what is present here. Also, we might want to compare with some drinks present in supermarkets. Like,
Yeah.
I guess we could take a couple.
We tried.
Yeah. I have
Run
some.
against whiskey, vodka, gin.
I have
and
some.
It's very different. I have a graphs. I can show you. There are
wow.
lots of measurements.
With,
where
with the
it's
same technology.
done. No, it's different technology.
Because I have a single malt finish Scotch
Yes.
Okay, we
in
can
my
try.
backpack.
But
Yeah,
this
of course
is just
it's-
the one. Let's try everything.
I want to try that because it does very good things to my brain.
Yeah.
Finnish single malt.
Is it there in your backpack? Should I bring it?
Yeah.
Let me measure another. The thing is that we could say how
Because
is
they'll
the
be
drink.
nice to compare that and this, right? In terms of.
You want
So-
me to add? I will add you the control.
Yes.
Would you like me to add control?
Yeah.
I think it was 50. Yeah, this is control.
Okay.
And let me.
And the control came from
Just the-
water, or what did you use?
The control will be here phosphate buffer saline, which is like water with some salt present.
Okay.
There's like ions, phosphate.
It's
And also with Gedre we might do controls, different controls, like having pure ethanol,
Yeah.
or we are going to have some materials present here. And as you see, control looks completely different. And this is our sample oxidation and reduction right here. Okay. So we already can say more. I would do different measurements for this one. I could measure analytical performance of the sample by scanning different scan rates and so on.
so we can try this one.
Yeah, 40.
Portwood Finnish single malt whiskey from Finland.
Okay. Now I'm just wondering, so we still have some sample left here, and I was wondering maybe we could save it. Like maybe we could use, do you have horror film or something just to save it, you know, if we need to run extra measurements for this one.
Yeah.
Yeah, so it's actually doing time plots, Elizabeth, on amperes, microamperes versus potential.